Every now and then there are fires on road ships and ferries. Rarely, but sometimes big ones too. And to stay safe in the future, we need to look into the reasons behind those fires and what allowed them to develop, to see how we can improve things. Additionally, we transport more cargo than ever, including new types of vehicles such as electrical and gas-driven cars. The good thing is that there are many stakeholders wanting to improve fire safety, and in the LASH FIRE project we have joined forces. Simply said, our objective has been to keep people and cargo safe, now and in the future. LASH FIRE has investigated the whole fire protection chain, from ignition to evacuation, and our solutions have been tested in their actual environment and evaluated with regard to cost effectiveness. Let me show you how it's been done. So, Francisco, how do we know what kind of cargo we are transporting and if it contains something that could cause a fire?
LASH FIRE has developed a solution that carries out scanning to identify what cargo we are transporting on ro-ro ships. The screening portal is a physical device located in the terminal ashore that supports identification of vehicles and detection of hotspots. We see that this is a solution that could be installed at every ro-ro terminal.
Most of the fires in ro-ro spaces start in vehicles, and especially in reefer trailers. Vasudev, how do we know if there's fire risk when reefers are connected and when electrical vehicles are charged?
For this purpose, LASH FIRE has come up with a monitoring solution. All the electrical connections to EVs that are charging and reefer units that are powered are constantly monitored by energy meters, insulation fault locators, and insulation measurement units. Every time there is a deviation from the norm or an anomaly is detected, the independent unit can either be disarmed manually or from the bridge. The key benefit of this solution is that an alarm is raised before there has been any actual damage or a fire situation has occurred on board.
If a fire still occurs, it is crucial to detect and visually confirm it quickly. Davud, what can be recommended for faster fire detection and confirmation if it happens in a closed or open ro-ro space?
We tested a wide range of fire detection systems, both in the lab and on board the ship. For closed ro-ro spaces like this, we found that video fire detection is very practical and affordable. For open ro-ro spaces where there is a lot of ventilation, linear heat detection is the most promising technology. Essentially, a linear system uses a strong sensor cable to monitor the entire length of the deck. And this means faster fire detection and less maintenance for it, compared to conventional smoke detectors and heat sensors. For visually confirming and localizing fires, we found that video analytics can speed up the process and make things safer. We also observed that thermal cameras can identify heated areas and visualize developing fires that cannot be detected using other sensors. And this means that thermal cameras are extra useful for proactive fire safety surveillance.
It is likely that new regulations will soon require fire detection also on weather deck. Have you identified any technologies that can do the job?
Well, we tested several technologies on board the ship and exposed the detectors to different weather conditions over a year. We see that flame detectors with triple IR technology provide excellent detection capability and durability, which is very important in this environment. Flame detectors provide rapid fire detection and have had no false alarms so far in our study. One of the video flame detection systems has also performed very well.
If fire has been confirmed in the cargo space, it is important to activate the extinguishing system as quickly as possible. Experience shows that human factors and design issues can slow down this process. Staffan, what can be done to help in this situation?
Yeah, so part of our approach here is organizational. So we know that crew members sometimes may hesitate when it comes to activation. And one way of dealing with that is through training. So we've developed a training course that is meant to mimic the conditions that you will find in a real fire scenario, including decision-making, communication practices, and practical activation. But then when you go through training, you will often discover certain areas of improvement, and there are many ways to build upon those discoveries. So we've paired the training course with a process that we call a reflection, evaluation, and change process. It's a systematic way of turning these drill experiences into workplace improvements.
We also know that bridge decision-making in a fire scenario can be made more efficient by well-designed and integrated systems. How has LASH FIRE approached this?
So what we wanted to do here was to tailor a decision support system around the needs of the fire chief who's in command during a fire incident. So we've worked very closely with end users, learning about the work that they do and getting their feedback on our designs. And we've produced a prototype for a digital fire central, what we call the DFC. So the DFC is a digital touch interface that brings together various types of information like heat spread and smoke spread, gives you access to safety system controls, and it also provides a timeline to help keep track of events as the response continues. So bringing information and controls together like this makes it easier for the fire chief to understand the situation and to make decisions. And firefighting on board is a time-sensitive process, and there is time to be saved by providing a well-integrated design solution.
The cargo space is normally packed with vehicles, including refrigerated trailers and electrical cars. Now let's go into the drencher station. Magnus, is the drencher system really able to control fire in all types of cars?
Yes, as a matter of fact, we have investigated this in the project by doing a series of fire suppression tests, and the conclusion is that a fire in an electric car is no more challenging for a drencher system than a fire in a gasoline-powered car.
If you have a fixed carbon dioxide system installed, there's normally a delay time until the system is activated. How did you address this in LASH FIRE?
We did that by developing a supplementary sprinkler system, and the idea is that that sprinkler system will activate at an early stage of the fire. It will keep the fire under control to allow time to discharge the carbon dioxide system. Thereby, the fire damage will be reduced and the effectiveness of the carbon dioxide will be improved.
So if we move to the weather deck, it is quite hazardous and difficult for the crew to manually fight the fire. Do you have any better solutions?
Yes, what we have done is that we have developed fire monitor system concepts. A fire monitor can discharge water or foam from a distance towards the fire. They can be remotely controlled or they can be autonomous. The advantage of an autonomous system is that the system is activated at an early stage of the fire and will discharge water very early to control it.
The ventilation affects the growth, intensity, and burning time of fires. Today, the ventilation system is shut off in case of fire in a cargo space. Anna, can active management of the ventilation system be used to assist firefighting in some way?
Yes, we have seen that using fans in the early phase of a fire can reduce the amount of smoke in a closed rotor space. This in turn improves the visibility, which would assist manual firefighting. How you apply the ventilation depends on the ship-specific conditions. If a fire is located close to an exhaust duct, having active fans will decrease the smoke density and improve the visibility. We have produced guidelines which intend to increase crew members' understanding of the risks and effects of using ventilation during a fire.
If electrical cars are catching fire in the roller space, the first recommended resort is still to activate the fixed system. But when it comes to manual firefighting of electrical cars, how should the crew tackle that? What do you say, Jaime?
We have tested different approaches to electric car fires. Which method to use in a real case will depend on the situation. For developed fires, crew can intervene with traditional fire hoses. Lighter hoses are easier to use in a rural deck packed with vehicles. Instead of using hoses, passive water cooling devices can be placed around the burning car to minimize the fire spread to other cars. During the post-fire stage, a fire blanket or a portable cooling device can protect against possible reignitions. The approach is not different from a fossil fuel car apart from the reignition risk. It is a matter of being prepared for possible thermal runaway fire events from the battery.
Okay, so if you have the fire under control, how should the crew proceed?
You can monitor the temperature with the infrared camera and take note of the temperature at regular intervals to observe the evolution of the fire. After the fire has been extinguished, fire suit must be treated as contaminated clothing.
There's a range of great fire safety improvements from the LASH FIRE project, some of which have already been implemented. Some will be relevant for new regulations, while others establish best practice and a basis for future research and development. And this will certainly make RoRo ships safer, both for passengers and for crew members.